do a fair amount of breadboarding, and sometimes I want to just test some discrete components and stuff. And I just get these little wall warts. And this one's just a 5-volt cell phone wall wart that was from some discarded thing or something or another. Check the voltages on it to make sure it's what you want. In this case, I wanted a 5-volt DC power supply. And this one's only like a half an amp. So it's probably not going to get away from me. And what I do is I strip the ends of it, make sure I know which one's positive, which one's negative. If you can't tell, you can use a multimeter to do it. And I strip the ends and I put on some little heat shrink tubing, and I put a little 2-pin header on here. And this one's a 90-degree one. And I like the 90-degree one because when you hook it up to a breadboard, it lays flat like that and it doesn't get in your way. It seems like when you're working on a breadboard, when I'm working on a breadboard, it seems like everything's just balled up on top, and so it's nice to have something under control. And for little projects and little testing things, it actually works pretty good. I've got an unboxing of the Fluke H7V Max coming up, and but let's see what the voltage is on this. And you can see it's quite a little bit high. It's 5.123 volts and stuff, so it's over 1/10 of a volt too hot. So the cool thing about these is they're often free or cheap, or you find them on the side of the road even. And if this one doesn't work out good, grab another one. I'm using the little spring clip on the probe because I'm having some interference here. Well, it's under 25 millivolts, and you can see there's some switching noise on here. So when I need 12 volts for like powering a stepper motor or something like that, I use these little line lumps, and these often have 12 and 5 volts positive and center ground. And you should check the label on it and measure them to make sure you have what you have. I think you have, like, let's see, this one is 5 volts at 2 amp, and it's at 12 volts at 2 amp. And the filtering in these probably is not going to be great, but at one time it was probably good enough to run a hard disk and without problems. So will be good enough for audio, maybe not. Will be good enough for like running stepper motors, probably. But also make sure that you test it to make sure it's good, and make sure there's not any like high voltage AC going through it, because for all you know, might be another reason why the hard disk case died or what have you. And so what I did unceremoniously is I just stripped the leads, and you can see one fraying. I've used it so much I've got to resolder this. But I stripped the leads, used a little heat shrink tubing on the ground wire. The one thing you have to be careful of these things is that these things can't tap together and short out and make a spark, and it'd be very unpleasant. But it's handy for breadboards because it gives you 12 volts, so you can have a 12-volt rail. And let's just make sure this is okay. Good, that looks good. And this is just kind of a, I almost said like did a Clivism, the classic operational amplifier a battery level meter using operational amplifiers, and the LEDs just go on when I raise the pot. And I'm going to just, maybe I'll go through this one in another project. But this has been really handy. I don't like the banana plugs, to tell you the truth. I think banana plugs are kind of bulky, and I've got to redo these. These are some really old ones that I've just taken off some ends of cables and stuff, and they lasted so long. And I'm going to reuse them again. And they're a little corroded, that's okay, because this isn't running a heart and lung machine. There are two things you have to be careful with when you're reusing line lumps and wall warts, is that not all of them have any indication that they're on, and they can be difficult to shut off. So this one has got a little LED, but if I wanted to disconnect this really fast, I'd have to yank the plug, which you can just see over here on this corner. And there's a power switch here, so you have to be careful. I really wish in all line lumps and wall warts that there was a power switch, and I think it would save a lot of power. I think that every appliance that you buy should have an on-off switch, a real, as Dave said, a real clunking power switch, and I think it would save a lot of power, notwithstanding. I figured that the fray in the wire had appeared in enough of videos, and I'm not one of those do as I say, do not as I do people. So I chopped the end off and skinned the wires, put some heat shrink tubing on this, and try to make some little, they call these pants. I try to make some pants for it, but you know, I can't, this doesn't have adhesive inside, so it only works so well, but it gives a little strain relief. This wire inside is actually green on this power supply, so I put a piece of heat shrink tubing just so I won't psych myself out and try to plug it into the ground. Anyway, let's see what it's putting out for voltage. And let's see, make sure on the voltage scale. So on the 12 volts, I've got 12.2, and on the 5 volts, I've got 5.196 or 1.97, and there's no load on this, and you know, maybe they had made it so it can have a little sag or something like that, and I guess you can't expect to have too good of an accuracy on this, but for a lot of things, this is fine, especially the 12 volt side, and for some things, it's probably not fine. Let's see what the line lump has for ripple. And I've tried to do a differential measurement with the Rigol 1054Z. I was not happy with the math capability. So it looks like the peaks, yeah, I'm getting some switching noise on this. So it seems to be on the 50, it looks like I'm getting about 20 millivolts of switching noise on it. I guess this could be filtered afterwards. You could put a pi filter, or actually EEV Blog. He actually had this really cool filter. I don't know if it'd be good for switching noise, but it's more of a ripple thing, but maybe some kind of filter would probably help this. This is on the 12 volt side. And this would be for the 5 volt side. And I'm trying to be careful not to short these together because it probably won't shut down in time. And we have about the same, you know, roughly 20, maybe 20 something millivolts of, in this case, switching noise. I don't have a lot of power supply, and I was hoping to do some experimenting with operational amplifiers with this. And so apparently this is an Elco GT3W, and it's a 15 and 15 volt power supply. It's got 0.8 amps on the positive and 1.8 amps in the negative, which is a little strange. So this looks like a nice little unit, and it probably weighs about 2 or 3 kilograms, and my scale won't go this high. Has some heat sinks in the back and some power transistors. On the bottom, there's an aluminum plate, and it looks like they took the time to grind it to make it look nice and pretty like this. And there's a bunch of screws on the bottom, and you can see I've already been in it. But inside, also we'll notice that the dye that they used for the anodizing faded a little bit, and it's kind of purpley. And that's what happens in the ultraviolet light, and oddly enough, powder coating doesn't do it that as badly. Underneath the dyeing, there's anodizing, and that's actually chemically changes aluminum into aluminum oxide. Anyway, you've got a little cover plate here, and it looks like this might have, I don't know, it was an extrusion that it looks like they sanded this to or ground it. And inside, we have a kind of a neat little wiring job. We have a toroidal transformer, and toroidal transformers are good because it kind of contains the magnetic field. And one of the cool things about this, and I want to show it to you, is this design. Look how they made this. Look at that. I think, and there's just two little things here. There's two little sides made from plates, and looking at it, you could do probably a fair bit of work on this without even taking it apart. It looks like the front is held on by these screws on the bottom there, and the circuit board slides into here. I've had this on within the last half an hour, and I didn't short out the capacitors yet, so I'm going to be careful. But it's got capacitors are screwed down to the bottom of the chassis, and it's not all glued. And of course, we know these are Japanese capacitors, and the rectifiers, and I believe these are rectifiers, are actually bolted to the bottom of the unit for heat sinking. And there's one on that side, and there's one on the other side. So, over here, and there is some bit of glue gun glue or celastic, whatever you want to call it, there, and it's got a little short cord. Oddly enough, this unit is I believe 100 volts. This isn't a 120 volt unit. I believe this is 100 volts, and this is a Japanese unit that was taken off some piece of equipment, and oddly enough, even though it's only really designed for 100 volts, it seems to work fine on 120. Inside of the 15 volt rail, there's one of these Hitachi HA17723 dedicated voltage regulators, and they're supposed to be like 0.02% maximum regulation. And the typical gets worse than that, like 1% or something. And apparently these can only carry about 150 milliamps, and so that's why they're using these power transistors and back to do the heavy lifting. And the rest is probably just filtering and a little bit of support circuitry. And there doesn't look like there's enough room in here for an IEC power connector, which is very unfortunate, and so it's just going to have to be screwed on. Somewhere on the end here, somewhere I'd like to put a power switch, some kind of indicator that it's running, and banana jacks. And oddly enough, one of our local places here, Fry's, they're not doing so good. And so I to tell you the truth, I miss just being able to go there and buy stuff. And I don't know if any of the other stores are open, but it's pretty sad. The wiring job is pretty neat. It's pretty neat, and I'm still trying to be careful because I'm tickling the dragon's tail here, which is actually a reference to the Demon Core. And if you look up Demon Core, you'll find out what tickling the dragon's tail really is. Anyway, so I want to put some binding posts on it, and we've got we have actually 100 volts here, 115 is going in there anyhow. The cool thing about this also is that it's adjustable. The both rails are adjustable. The plus 15 and the minus 15 are independently adjustable. So here's the dilemma. There's only so much space between here and here, and if I put a binding post in here, you can see that this thing's all the way to the back of it. I don't know, maybe, I don't know if this part is molded in really tight, but maybe I could leave the screw off and snip this off of maybe here. Maybe it wouldn't be too deep then. And I had an idea. Rather than messing around with alligator clips onto this thing, and I can't put binding posts on this right now, I can put banana plugs on this, and I'll put these on here, and I'll take one of these wires off, and I'll probably get rid of this little vinyl solution because this is too stiff. It'll pull the breadboard right off. Hopefully these are in two separate terminals, because if I can get rid of one wire, that'd be really good. And cut that off here, and I'll just slide this off of here like so. Like so. I don't see any washers in here. Looks like there's washers, but there's not. You always want to make sure that the power's good enough for this. And I can put this little shield over here. You can still get your fingers in here if you really tried, I think. I don't know, it'd be a good job for black tape. And you have to be careful if you're going to do this with a screwdriver, because this is conductive. And I find it to be handy, but still, it's conductive. So I'm going to braid these, and I put this, keep on moving one over the top of the center. The outside one goes like that. I'm just using a pair of wire strippers to strip these. Like so. It's hard to do this far away from what you're doing. I'm actually at arm's length right now. I have these old ancient banana plugs, and you can see it has a set screw, so the connection will be really good. Well, the least I can do is tin the leads, and so I'm going to do at least that. And let's get this where you can see it. And I'm soldering at arm's distance, so this is kind of funny. And I'm not being very pedantic with this right now. I'm just going to get it wet with solder. And then I'm going to trim them a little bit. I'm trying to really soak these though. Like so. Get rid of the extra solder. And like so. Oh, I didn't explain the soldering iron. For some reason, this tip on the soldering iron, it still works after 15 years, and I've done a lot of soldering iron. I soldered together my whole CNC machine, Arduino stuff, everything you saw on this channel, much more. And I don't know whether to trust the scope or this multimeter. Maybe this multimeter's about had it, but roughly 15 and minus 15. So I wanted this for is working with operational amplifiers. This is the right motherboard, but the wrong project. This is actually just a DC project, and I'll show this off in another video. But what I wanted to do is just be able to plug this in here and put plus 15 and minus 15 in there somewhere, and yeah, I think it'll be fine. I'm going across the ground from the ground to one of the power pins, and this is the negative. Oops, if I can get it steady. If I can keep it steady. Anyhow, so I've got something going on. This might be the regulation frequency. It might be something coming in from the line, but it appears to be about 30, probably say 20 to 30 millivolts, and so that's not nothing, and this could be filtered better. And let's see what we have here on the positive. Probably about the same. I don't use this clip very much, but this is a special occasion. Yeah, and here I'm getting about 30 millivolts of junk, and it seems to be, I don't know if it's this I can't be sure this is all from the power supply, and like I said, I've had problems with power at this corner of the apartment. My friend Jack gave me 2 of these power supplies, and they're quite old. They're probably from, like, maybe the late 70s or early 80s, and I looked on the internet for information on these, and the closest I can find is Kerry Wong has one. He has a great YouTube channel, lots of good stuff, really neat stuff. As you can see, the unit's pretty dirty, and it's probably moldy as well, and so I'm doing this outside. And there's 8 screws to open the unit. If you look along the side here, these don't have to be removed. This has to be removed, this, and this, and then it'll give you access to it. And I'm not going to probably go through the whole cleaning procedure in real time, but I just want to give you a first peek at this. So the cover slides off like this. You've got some embedded number here, unless this is this might be a serial number here. And I don't see a lot of rust. The color hasn't faded too much. Looks like it's been opened a few times. Let's set this aside. We have actually a fairly nice circuit board. Not everything's populated. There's a capacitor not present here. There's it looks like a transistor not present here. It's a Q, so it's likely a transistor. You've got 2 resistors missing here, slow blow fuse here. You have some corrosion right here. This should probably be cleaned here, in here. A lot of dust in here. Patent notice. And the wiring, as Kerry Wong says, the wiring is it could be a little neater. And there's a lot of dust on the resistors. The resistors are often like this resistors, and these 2 resistors are proud of the board, so if you smoke them, there won't be a problem. Speaking of smoking, this diode here looks like it's got some little smoke trails on it, on the lead, oddly enough. So I'm not terribly confident in this right now, because I saw that bad diode, and I don't completely trust the device under test, and so I'm going to test it outside first. And so I've got a multimeter, turned it on. I've got it set to DC volts on 200, because this does go up to 60 volts, and holds off. I've got the probes in the right place. This power supply, it looks like a positive negative power supply. but as far as I know, one of these is not by itself. I think I think there's a way you can put two of these together, either in series or parallel, to perform some action. A series would be cool. Actually, it'd be cool if you could do both, because I'd like to have it'd be cool to have a positive negative power supply with asymmetrical rails. That would be pretty weird, but there might be use for that. Anyway, so I got my test probes on. I cleaned the inside of the banana plugs. They were dirty, and I didn't use anything abrasive because I don't want to take the plating off. I just want them clean. Let's see. I put the current limiter on some appropriate amount, and I turn the voltage down and the fine voltage down. Actually, I put the fine voltage in the middle, turn the voltage down, and I'll plug it in. And let's see what we get. Let's see if we can get the circuit board in too. I don't know which side would be the action side if this thing goes up, but let's try to get the circuit board in there too. You can see the meter. And I've got 96 volts. That's a little hot. That's 96 volts DC. So that's not good. And yeah, that's on the 200 volt range. So there's something wrong. It's all the way down, and I have 96 volts. I have no voltage control here, and so that's not good. And on the other one, I could shut off the current, and I would still see. On the other one, I could shut off the current, and I would see nothing, but I'm seeing 96 volts. I'm curious to whether or not it's positive or negative. You could see that CR107. It's not only smoked, it's cracked on the bottom right there. And I suspect that's a diode. I don't know if it's a Zener or not. Almost tempted to throw any diode in there and see what the result would be. And I don't know anything about this chip. It's a Motorola chip. I'm not terribly enthusiastic about being able to find them. And but this is probably the main voltage regulator I see. I got two kinds of diodes. One's even smaller, and the other one's larger. I'm gonna try the larger one. I'm gonna bodge it in because I don't want to disturb the board yet. My first lookup, I couldn't find anything out about this diode. I don't believe it's a Zener though. There's two Zener diodes, and they're marked, or at least there's unique Zener diodes, and they're marked. And I'll get a kick if this is the only problem, but I don't think this is the only problem. I think it would be naive to think this is the only problem. You know what they say, it doesn't usually roll downhill. Oh, this is bad. This is bad. There's a trace gone. Look at this. It's a good thing I took this out. This trace is totally gone. There's look at this. This is pretty graphic. So there's a smoke trace over here. Looks like I got some corrosion here, but this is smoked. This trace does not look happy, but that looks like it's. This looks like it's, this one, it looks like it's involved in the, oh, it doesn't feel good either. This trace actually might be okay. This one might be okay, but, this is bad. I don't know what happened here, but, and the funny thing is, all these wires are really low current wires. I mean, look how thin this wire is right here. Look how thin that is. But it was strong enough to blow out. It was strong enough to take out this trace. I'm going to load a little solder onto these pads with the idea that flux will clean the pads. Ironically, I found this wire. I go for a walk every morning, and there's this one telephone box, and they're in it every week, and they're always, it's a constant source of scrap wire. And there we go. I'm going to release it from the proof mass or the rock or something. And unfortunately, I think I'm going to put the board back in place when I test it, because who knows, when I'm flinging the thing around in the yard because of the fire, I might get upset, and I don't want to cause any extra damage to it. by throwing it around the yard when it's on fire to put out the fire. The thing is that I feel that there's probably upstream or downstream damage from the original problem, from this problem, I should say. I brought this outside because if I let the steam out of these capacitors, I'd rather it be outside. And as I said, there's probably problems upstream or downstream that caused this problem. But who knows? There's always a chance. And if this doesn't work, I guess I'll try to track down all the transistors and the electrolytic capacitors and replace them and see if I can find this voltage regulator IC. And if I can't find the IC, I don't know. I'm going to feel a little weird about putting money in for all the power transistors if they're still available. Anyway, so I've got this on the 200 DC scale. I'm going to adjust the current to just off the 4. I'm going to adjust the voltage all the way down. Power's off. Probes are connected. Nothing's touching the air conditioning to be grounded. Yeah, it's an old air conditioning down here. Okay. So if this meter pegs, it's probably going to be bad. It's pegged 96 volts. Well, that's that. So I've got 2 of these Lambda power supplies. As you saw, one of them is in pretty rough shape. I did some checking on the internet. Unfortunately, the main IC for voltage regulation is an old Motorola part that was proprietary, and it's no longer made. There's a couple of them in some countries. They're pulling these apart and pulling the chips out of them. And but right now I can't financially risk fixing the other one, and I likely at some point financially risk fixing this one up, putting new capacitors in it, but the other one I just can't justify it. And so I'm gonna save the chassis. I'm just gonna basically shelve the project. Maybe I'll find the main IC for it. Maybe I won't. But for right now, I can't quite do it. And fortunately, one of them works, and it's actually pretty cool because this thing puts out a maximum of 60 volts. And so let's see what it has for ripple. And we'll bring up. I think I gotta bring up the current a little bit so I'll have some voltage. Yeah, we'll put about 10 volts. And I've got some noise on this. Well, I'm on the 50 millivolt scale. I've got just over 50 millivolts. It seems to be in the hundreds of kilohertz. It's almost switching frequencies, but I know this is a linear power supply. And so anyway, so a little filter would be good after this and stuff. And I guess this is what I have to use for right now. And maybe I could do a little filter afterwards or something like that. And also, as you can see, it's pretty frisky in here. And even if I ground this, actually, that's not bad if it's grounded. But anyway, so the other one's going to get shelved. This one will probably get used. And at some point, I should put new capacitors in it because something's getting through. And or make a filter afterwards. Unfortunately, this isn't positive and negative voltage. It's got like a ground reference, and these were made so you can pair them up. You need an entire other one to do negative voltages. This might be it for the this old power supply video, and maybe at some point I will fix this up. I'm not keen on just throwing things out, and if they could be repaired, they can be repaired. But unfortunately, as I said, I don't know if it makes financial sense to fix it right now, and I got some financial stuff going on. Anyway, thanks for watching. Subscribe, watch some videos, and take care.